the video.
that we would never have to say goodbye. Girl, you changed my life, and I could never leave your side. I swear I'm here for life. It feels too right when I'm with you. Every problem fades away. I can never run away.
Try not work.
When I'm with you, I put everything away just to have you one more day. Yeah. When I'm with you, always feels like a sunny day. You move all the pain away. Yeah, I'll never be the same. I could never leave your side. I swear I'm here for life. It feels too right when I'm with you. Every problem fades away. I can never run away. No. When I'm with you, I put everything away just to have you one more day. When I'm with you. I'm feeling free with our bodies together as I breathe. I'm lighter than a feather when I'm with you all day, all night. Every moment so good, so good. Got something so sweet, yeah, it's charming. Make me wanna see you more every day. Go down like a tree, night and morning. Maybe you're the one who I want to stay. So tell me if you feel this, baby. My mind is running crazy, 'cause no one has made me feel this way. You do everything perfectly, and I want you to see that I appreciate you. I'm feeling free with our bodies together as I breathe. I'm lighter than a feather when I'm with you all day, all night. Every moment so good, so good. Green light, oh it's true. I've never met nobody who's like you. This time I got so lucky when I'm with you all day, all night. Every moment so good, so good. Green light. You got the green light in your eyes and your smile, yeah, yeah. Know I would spot you from a mile, can't why, yeah, yeah. I think you're my one and only. I know it 'cause I dream about you. So tell me if you feel this, baby. My mind is running crazy, 'cause no one has made me feel this way. You do everything perfectly, and I want you to see that I appreciate you. I'm feeling free with our bodies together as I breathe. I'm lighter than a feather when I'm with you all day, all night. Every moment so good, so good. Green light, oh it's true. I've never met nobody who's like you. This time I got so lucky when I'm with you all day, all night. Every moment so good, so good. Green light, oh red, oh amber in your body. Only green light, only green light. No red, oh amber in your body. Only green light, only green light.
We both know those moments when all your worries hit again and eat your time. So let's just pretend that it'll work out in the end and turn out fine. Yeah.
Every night crashes down on you like an avalanche, opening up the deepest parts of your thoughts, and all you find is deeper shades of blue.
So let's dance for hours, letting time pass like the wind. What's on your mind? But leave that behind and let loose. Show your problems out the door and let loose. Ain't no worries on the dance floor. Just let the weight of your shoulders show 'em what you're made of. Right here, right now. Ain't no worries when you let loose. Tonight, let's remember that the past is in the past. It is our time. And you won't forget this and definitely not regret your hand in mine. All of that mess just dissipates when you look at me. Nobody else around is dragging us down, and now you know there's one thing left to do. So let's dance for hours, letting time pass like the wind. What's on your mind? Leave that behind and let loose. Show your problems out the door and let loose. Ain't no worries on the dance floor. Just let the weight of your shoulders show 'em what you're made of. Right here, right now. Ain't no worries when you let loose. It's all in the past. No looking back. Just you and me here tonight. We can't change the past. Can't take it back. We can learn to let go and let loose. Show your problems out the door and let loose. Ain't no worries on the dance floor. Just let the weight of your shoulders show 'em what you're made of. Right here, right now. Ain't no worries when you let loose. Hold on to hope, don't let go. Don't give up, there's rest for your weary soul. And time to heal, yet still you fight with what you're told. And hold on to your scars and wounds and past before. And I said, ooh, what would you do if you could lose all your burdens? Yeah. And I said, ooh, my words are few, but I love you. Those words, please hear them. Yeah.
Hasn't the pace been alarming, honey? But take a look at where we are. Haven't we made it, my love? Oh, honey, look how we made it this far. Hasn't the pace been alarming, honey? But take a look at where we are. Isn't the day so exciting? Oh, honey, when I wake up, I'm feeling brand new. All I can say is I look like new money, and the only thing I know is true. I owe it to you, you, you. I owe it to you, you, you. I owe it to you, you, you. I owe it to you. You shine like a ray from the sun. There's something people look for but never can find. I swear you're the gold I've been running for, honey, like I woke up and won the top prize. So many days feeling cold and too lonely, sitting all the time living in blue. All I can say is I look like new money, and the only thing I know is true. I owe it to you, you, you. I owe it to you, you, you. I owe it to you, you, you. I owe it to you. Always thinking about that. Sick of being changed. Take me back to cigarettes. Forget about the time.
Everybody get up.
Carnivals, get alright. Let the ashes fall. You and me together. Forget the world time.
Everybody get up. Wait a minute, cut this shit.
Always thinking about that. Sick of being changed. Take me back to cigarettes. Forget about the time.
Everybody get up.
Carnivals, get alright. Let the ashes fall. You and me together. Forget the world time.
Everybody get up.
Hooked on you, baby golden. Time moves, I never know. It's just can't get enough. Got me wonderstruck. I keep on waiting for the hurricane to come and wash the magic that you brought away. But somehow all the colors just keep getting brighter. Yeah, I'm feeling it more every day. I think I'm hooked on you, baby golden. Time moves, I never know. It's just can't get enough. Got me wonderstruck. I knew the second I met you, I was doomed to never forget you. Just one single touch got me wondering.
by tomorrow. Don't worry, that's the motto. So we keep moving along. Ooh, dropping down a Cabo in the sunburned El Dorado. Don't worry, that's the motto. So we keep moving along.
Look at you try to lie to me, but I don't really care about it. Last year you and I, we had a summer fling. I can't get over thinking about it. Suspense, can we be just friends? We say it over and over again. Depends when the weekend ends. You know we might be in trouble. I can't get you out of my mind. Tastes like summertime. Wanna jump in? What you gonna do? What you gonna do? Jump in. Stop up and jump in the deep end. I'm gonna take your time, say, "Got my favorite drink, that's so no shit." Wanna jump in, feel it. The water's warm, so honey, won't you jump in? I think you got a little piece of me from one night that you last year might be a big reason I still think about us in the skylight. Deja vu, I want you so real, 'cause it feels like I never really lost you. I don't wanna let you go this time. Let's pick it up from where we started. I can't get you out of my mind. Tastes like summertime. Wanna jump in? What you gonna do? What you gonna do? Jump in. Jumping in. Stop up and jump in the deep end. You know it's so toxic. Oh my baby, drink that's summer passion. Go and jump in, baby. You know you taste like summer. Wanna jump in? Jumping in. What you gonna do? What you gonna do? Jump in. Step up and dive in the deep end. I wanna take your time, say, "Oh my baby, drink that's summer passion." Wanna jump in, feel it. The water's warm, so honey, won't you jump in? Jumping in. What you gonna do? What you gonna do? Jump in, jump. Stop up and jump in the deep end. I wanna take your time, say, "Oh my baby, drink that summer passion." Wanna jump in, feel it. The water's warm, so honey, won't you jump in?
Well, I gave you all my love and I gave you all my trust and I gave you everything that you need. But you only told me lies and you made me realize that, babe, you ain't no good for me. I can't be with you, you can't be true. And I know just what I got to do. Gonna hit the ground running, running just as fast as I can. Gonna hit the ground running, running just as fast as I can. Ooh. ground running, baby, I'm running, baby, I'm running, 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 wild, running, running.
So hello everyone, can you please take your seats? We will start in a minute. No, to mám si stát. Možná značku. So, hello. I'd like to welcome you on the next Cloud Native Prague Meetup. Today, we will be speaking about stateful workloads, and also in the Kubernetes. So, first of all, something about us. So, I'm Zdeněk, I'm the CNCF ambassador, and I'm organizing these events with Pavel, there, with the orange hat. We are making it in our free time, so, you know, it's a community event, so you have to take care about it. So, what is CNCF? I hope that you know it. What is CNCF? But I have to remember. I have to, mention it one more time. So, CNCF is a foundation which helps the open source project to grow. That if you wanted to find some contributors for your project, you wanted to be more visible for the companies, so you can become as the CNCF project, and then it should help you. And I think that you know some projects like Kubernetes, Prometheus, Argo, and stuff like that. So, something about our community. So we have the webpage, cloudnativeprague.cz, so you can subscribe there, and you will get the emails about upcoming events. We have also Slack channel. You can check our presentation at slides.cloudnativeprague.cz, and also we are making records from these events. We have YouTube channel where you can see there. If you wanted to help us, like providing this space, or speak at these events, or just help us with the organizing, so there's just Google form, involvement.cloudnativeprague.cz, where you can reach us, or via Slack or LinkedIn, it's up to you. So, we are not alone. There are more communities in our region, like Golang community, Python community, DevOps communities. So, I like to introduce some of them. So, tomorrow, there will be a DevOps Days conference, if you don't know about it. You can, if you are not registered, you can do that, I think, till today, 11. You can use the discount code CMP Rules, which is 50% discount. So I think it's good. There is another conference, it's KCD. It's organized also by me. You can use discount code CMP_community if you want. It's in Bratislava this year, but we made it last year and next year in Prague. And the last one is if there's someone on the stream from Brno, for example, so there's a Web Science conference. It's 10th June, so you can check it. So I'd like to welcome T-Mobile, because they provide us this amazing place, and also catering. So please make some applause for them. Thank you. So, you have two speakers. First is Martin from the T-Mobile. Can I call it T-Mobile? Or? Okay. He will be speaking about, I think, very interesting topic about the calls and how it works with the streaming. I have no idea how it works, so it will be interesting for me. And the second talk will be by Andrei, and he will be speaking about the Cozystack. So I really enjoy it. So that's it from my side. There's the QR code for the Slido. So yes, sorry. I see something different on TVs. So, okay. So is the QR code for the Slido. So please, if you have any questions, use Slido. We can also have questions from this audience, but we will prefer the Slido for the voting. So we'll wait. I think you can see also the codes on another TVs, even during the talks. But that's it from my side. So thank you. And I'd like to welcome the first speaker, Martin.
Thank you. I think it doesn't even work. I think. Take another one. Not really. I think we need someone from the production. There were some tests.
I guess you need to open your presentation, or I'm not sure how it works.
Let's see. Yeah, it's coming up, don't worry. All right. Oh. Nice, perfect. So hello and welcome to my call, to my presentation about messaging calls and videos in Kubernetes, the Kamailio and RTPengine way. My name is Řehořek and I'll guide you through this presentation. So something for the agenda. So firstly, we're going to talk about the introduction. Who am I? What's the company? About Kamara project, telco transformation. And then in the next section, we're going to talk about the journey to cloud native voice. Why is it made? How architecture, voice simplified view. Then in the next section, we're going to talk about open source stack for real-time voice. Nice, sounds good. What is going to be the main focus? Finding the right tools for this, setting it up, Kubernetes objects overview, what you need for it, additional work and tools that you might need. In the next section, we are going to show you what did we achieve. That following up, it's going to be demo of our workflow that we have prepared for you. We're going to have SN graph for call flow and then some challenges. Some project without challenges, I think it doesn't exist. And you might see some challenges that we faced during that. And lastly, we're going to have a conclusion. So let's start with the introduction. So you might see me on the picture. I usually attend these events. My name is Řehořek. As I said in the beginning, I work for Deutsche Telekom, as you might see the logo in the bottom. You might know it from T-Mobile Czech or T-Mobile Slovak or T-Mobile Poland and much more, the subsidiaries. I'm a DevOps engineer working under DT for almost 3 years. I've been included in projects as 5G, the project that I'm going to show you, CPaaS, and automation. And for those who don't know Deutsche Telekom, it's a telecommunication company made for producing us and creating us voice traffic, SMS, data, 5G, IoT, and our own cloud, public cloud called OTC. That's something for the introduction. And a bit of a nostalgia for me. I was here 2 years ago on my first Cloud Native Prague event. You might see me on the picture there. It was the 6th, and it's the same place, and I'm really happy that I can present you with something of our own. So, for the introduction, the Kamara project, maybe you have heard about it. It's our contribution to the CNCF community. Kamara actually is just a way on how to work with API, standardization, so that developers can easily develop, test, and use the APIs. You can see the points that it has and provides. And we can see on the picture from the keynote on the KubeCon 2025 in London, that was mentioned as well with some other projects that are dedicated to Linux Foundation. So last part of the introduction is the evolution of telco. And as you might see, another picture from the keynote in London. And as you might see that the voice has naturally developed, new generations came, and we're going to focus on the transition from 4G, fourth generation, to 5G. And if you don't see it, I will tell you that the 4G is the step where there was virtualization and disaggregation to virtual network functions. And we are currently looking into the next step, which is the 5G, and that's containerization. And also some appropriated tools used, I don't know if you can see Kserve for AI or some IoT devices and much more. So this was a thing mentioned from the Vodafone perspective, and I think it's quite the same for other telcos. So now our journey to cloud native voice. So the question, why did we want to do it in the first place? So you can see maybe the $ that we wanted to have cost savings. And it's connected with the sustainability and scaling, right? Because if you can have a platform that can scale down and don't use resources such as energy or electricity and water and stuff like that, it's healthier for the environment, right? So that's a good thing for us. The third point is the scalability. As I mentioned, usually you don't call anyone during nighttime. Who calls someone at 1 a.m.? Probably no one, right? So why do we have to pay for infrastructure that's running this in the cloud, right? Why don't we just, scale down or scale up if there's a football event or Mother's Day or some significant day, right? And the fourth one is knowledge, because this is evolving. This is a new era, new generation. So we want to gather some knowledge in this era, right? So that was the fourth point. Why did we start this journey? And also, you might see the sentence that Nokia is already looking to cloudify the voice, and that we know that the voice race has begun in this transition. So for you who don't really understand what is it about, what's actually deployed, I prepared for you a simple presentation of the simplified voice architecture on the diagram. And as you might see, that there are two actors, operator A on the left side, operator B on the right side, and that we have some network components such as the voice load balancers, the SSC, which is signaling session controller, and MSC, which is media session controller, I think. And I will guide you through a work process or how it actually works. So an operator creates a SIP invite, which is a protocol for signalization, and it gets to the voice load balancer. After that, it sends this request to one of the, let's call it SBC, which is like a group for these two network components. And this is session border controller, known as SBC. So it finds one trunk or SBC that it wants to connect to. Then it goes to the SSC for signaling, so this request comes there. And it will initiate communication with the MSC, which is a media relay. It does the heavy lifting on the media, transcodings, and much more. And this SSC is just part of the flow for the signaling. So we have this part covered. It tries to find a voice load balancer that is closest to the operator B to send this request. And after this signaling is accepted and connected, then the RTP streams are protocols used for media. And if everything goes well, then they can hear each other. So now we know the simplified architecture. Now we need to find the right tools to solve this project problem, this new generation, right? It would be good that it could do the heavy lifting. We wouldn't need to come with it up ourselves. We could just use some open source, right? So let's see what we really want to put in the cloud, and that's the SBC, because it does the heavy lifting for us. So our team had few people, but big plans, right? It's quite difficult to put this into cloud, as major companies are using the virtualized network functions. We called it a CEVO, which is abbreviation for containerized evolution of voice for us. And we had two main objectives: to create a small voice platform that could be in the cloud and also use open source technologies. And also the second part was gaining experience in running voice applications in Kubernetes. So we know now what we want. Let's find the right tools, right? Read some research, look into presentations, look into academic papers. And so we did. And we have another 3 questions for that, right? So in the picture, if you remember, we were looking for something for signaling, media, and also it would be nice to monitor, right? If you have multiple calls, hundreds, thousands, millions, right? You need to see what's wrong, or if someone has a jitter or it doesn't work, right? So you need to look for these tools to implement it. And for the signaling, we had multiple contenders, one of them being Kamailio, as maybe you heard from the title of the presentation, Asterisk. There's also FreeSwitch and multiple other open source tools that you can use and is at your disposal. The main, I think, key difference between Kamailio and Asterisk is that Kamailio is just for signaling. It's high performant. It can handle millions of calls just by one instance. So it's really performant. It's also open source, right? We are talking about open source. And I think the benefits were also that there are modules that are extensible, that you can view the documentation, use what you want, don't, what you don't want. And that, in comparison to Asterisk, it's also the same, but it includes also media. So it's not isolated, the signaling and media part. It's just one thing in bundle. It works nice, but it's compute heavy. And you want, something that's not really, connected to each other, so that you can, scale maybe one part, not really, scaling the signaling if you don't need it, right? So this was our decision to pick Kamailio here. And then the second thing that we were looking for is the media relay, media proxy, or the media transcodings, right? So there were 2 possible ways, and we were mainly looking for something that's integratable with Kamailio. And as you might see on it being highlighted, both of them integrates with Kamailio. And for us, that we used something in production with also RTPengine, we were sure to use the solution instead of the RTP proxy. They're quite the same. Configuration is also similar, not even maybe the same. And they have also features that you can read on, but for us, it would do the same job. So we opted for RTPengine here. And also something for the monitoring, right, would be nice. And we figured out that there was one tool called Homer. You can see the logo on the right side. And it provided us an open source monitoring solution, integratable and made and tailored, to be honest, to Kamailio. So that was nice, right? You could analyze the packets, you could see the traces easily, and you could just have a monitoring tool at your disposal. Nice. And I wanted to mention that there are 2 versions. One is the old one that has a different architecture. As you can see, the tech stack over there, and essentially is like a web GUI that you can use in your monitoring stack. And the new one has something new. It's built on Grafana, so you have dashboards there, and much more over in this solution is more adaptable. You can change, you can create your own dashboards, right? Instead of in the old version, you can't really do that. And I can show you, this is how the old version looks like. So you have just normal UI. On the left, you have filter. On the right one, you can see the individual messages from the zip. So that's that. And also the new version, I'm sorry for the quality, but this was from the original documentation. You can see the Grafana, and that it has some pre-built dashboards that you can also filter and see the voice calls, or call flows, sorry. And with that, I can see that you can also make some, also some, you can build anything you want there, to be honest. So now we have the tools, right? So it would be nice to see, and put it into the architecture picture. So one more step deeper, and we have the Kamailio substituting the signaling module. We have the RTPengine to substitute our media. And also we have Homer in addition. And you might also see MariaDB connected to Kamailio because Kamailio has the possibility to use external database. So with that, we can move one step, inside, and we can view the. I kind of broke it. Sorry. Now you can see an environment that is called air-gapped environment because it can't use internet or it can't be, ingress or egress, nothing there. So you need to use specialized proxies and stuff. So I present you with the simplified view of the architecture plus the actors and requests. So I would firstly start with the infrastructure. As you can see, I already told you about the environment. You have Kubernetes cluster there, and also you have an infrastructure as a code environment where we deployed some virtual machines. So I would talk about the first flow, and as you might know, GitOps principle and approach. You have a developer that pushes a code, and Argo CD pulls the changes and applies it to the cluster. Then we have the second flow, which is the people under the diagram, and they're called Martin and Ronnie, and they want to make a call, right? So firstly, I send a SIP request. I would like to call Ronnie to the load balancer, and after that, it does its magic and goes to the cluster, finds the correct pod, and then sends a SIP request back to Ronnie. I want to call you, right? And what needs to be done after it accepts, so this bidirectional flow, he will accept, and we can start sending RTP traffic through the RTP request, if you can see them. So that's the second flow, and in the third flow, we can see the two virtual machines being dummy operator 1 and dummy operator 2, what you would see in the real traffic. And dummy operator 1 would do the same flow, calling the SIP request to the load balancer, finding the right pod, then contacting dummy operator 2, and then establishing RTP streams. So that's the main workflows that you might see. I know that we put some logos there, but there's much to it. Just a simplified view of the architecture. And we also seen on the internet that there's some tools or projects that you can learn from. One being full WoIP service on Kubernetes. We looked into this and have a similar approach to this platform. So if you want to look and really see, how could you do it? There's a deployable Helm chart, I think, available at the GitHub mentioned over there. So we probably know what we need to do, but how to set it up, right? So documentation is your friend, or is it? Because there are multiple versions of Kamailio. The documentation is not so up to date with these versions, right? Like you can have a major documentation for one version, but not for the other. And if you see some blog post about this version, and you can see that it's not, working on your version, right? So it's a bit of a documentation hell, but if you dive into the documentation, you can definitely make it up. And how are the Helm charts, right? We want to deploy it to Kubernetes, so it should be somewhere, right? During the research, I found out that some Helm charts were deleted or put into private. So I can then guide you how can you find some, good Helm charts or some star that you can, work with. So for the RTPengine, there's a Phonoster project that has the RTPengine and also Kubernetes objects and Helm chart. It's public, you can view it, you can find it on the site, on GitHub. And there's another project called Jambons. And there you can see a lot of tools, but one of them being RTPengine and Kamailio. So you can definitely see some examples of Helm charts and Kubernetes objects that you can, refer to. So here is our minimal setup, what you need for the Helm chart. It's structured into three, let's say, types of Helm charts. One is Kamailio, one is database, and one is RTPengine. So a bit kind of standard, I guess, deployment, but I can guide you through the Kubernetes objects. So config map, easy for configuring the Kamailio and the instances, right? Deployment, again, classic, how you're going to deploy the instances, right? Service, headless service is interesting because you need to have the IPs of the Kamailio instances for them to be able to synchronize. And classic load balancer and secrets for secrets management in the Kamailio configs. The next one is database, a bit standard. I think I don't need to really go over that. And the third point is quite interesting because you have RTPengine. And the standard way, and also in the academic paper, we saw that they are using daemon set. And if I'm not mistaken, you can use one pod per, there in individual node, there's one pod running, right? But you don't really want that because you want to scale, right? You don't want one pod handling 150 calls. You want millions, right? So in this way, we opted for deployment, and it has its difficulties to maintain it, to provide the configs right, and to update it. But again, similar stuff as in Kamailio. So I mentioned the configuration, right? It's a bit tricky, because the main configuration lies in 2 or more files, one of them being Kamailio CFG, and it contains around 1,100 lines on the main branch. We had around 1,600, but definitely we had something more included that wasn't necessary, but for our documentation purposes. And it's something like a long list, really like a good old config file. And you can import the other files if you want to. It's extensible by the imports. And it can be a bit difficult to hard to read, as you might see in the following slides. So here I just took, I think you might understand a bit of the code. You have routes, which are something like functions. You have returns and other keywords. I don't know, possibly you might know that xlog is just logging it in the console. But it's not that difficult, I guess, to write. But there are certain variables that you need to just look into the documentation, know what they do, what are the parameters, stuff like that. And another thing that we need to do extra was the synchronization module, or like an operator that was talking to individual pods, seeing if they have the configuration ready, if everything works. So that was our additional work that we needed to do. And we found out that there was another solution, quite nice, as I mentioned, with the console on the open source project that you might view, that they were handling these network, I guess, configuration things with console. And additional tools that you might want, and one of them being KubeShark, but as I mentioned, it was air-gapped environment. It was not really usable with the permission it had, so we couldn't use it. But it would substitute TCP dumps and Wireshark, troubleshooting and analysis, what's going wrong. And another great tool is SNGrep, which you might see in the bottom right, and it essentially shows you the call flow with the parties, the call lags, the SIP requests, also the data as well. And another great tool is SIP-P, used for testing. So if you want to do traffic of 100 calls, you might need to opt for SIP-P rather than just doing it on your own manually. So a bit of an automation. So now comes the good part, right? What did we achieve? So we deployed it on our private infrastructure. We created successful calls with SIP-P, so multiple hundreds of calls. We used SIP agents, something like Linphone or Zoiper. Essentially, it's like an app that you can use to create SIP calls with. And we created calls, video calls, and messages. I know it might sound like WebRTC, but we were just extending the scope of what it can actually do, but we were focusing mainly on the calls. And we were able to scale to XPods. So the scaling kind of worked. And we also learned about what we wanted, and that's the voice ecosystem in the cloud, right, in the Kubernetes. But also the benefits and challenges that came along the way. So now I would show you a video that we prepared for you with my colleague Ronnie. It's going to show you a simple use case that we thought of showing you what it actually does. So I think we can play the video, I think.
Teams are not working. WebEx is now gone. Well, what should I do? Oh, wait. I have Siebel. Let me call Ronnie.
Oh, Martin's calling.
Let's do a video. Oh, hey, Ronnie.
Hey.
Wanna meet for lunch at the INMC in the canteen?
No, I don't like the canteen in Frankfurt. How about the burgers downstairs?
Sure. Let me be there in 5 minutes. See you there. Bye.
See you. Bye-bye.
So the joke was there that there's no canteen, it doesn't exist, but I know that you might know about that. But this was such a demo that, showed us that it's actually feasible to run it on a private infrastructure and, with the components that we had and the minimal setup. So I can show you how, again, the call flow looked like. So on the bottom left, there's me, Martin, calling Ronnie, going through the load balancer, finding suitable Kamailio, finding the right RTPengine that has the ports available, and then contacting Ronnie. Hey, I want to call you through the Kamailio, and if he accepts, then the RTP streams can flow through us, and we can send data. And also here you can see the SN grep. So in details, you can see the call lags, Martin, Kamailio, and Ronnie. The Kamailio is in the middle, and I'm sending a invite request to Ronnie. It goes there, it's trying, ringing, and then it comes to me back. Then I respond with OK request, and that we are sending data, and at the end we have bye. So we just canceled the call, and this was essentially what you just saw on the video, but just behind the scenes. I needed to remove certain information from there for security reasons. Sorry for that. So this is nice, right? It looks like it works, but there were the challenges. So first of them being the homer, actually. Because we tried so hard to set it up correctly. We wanted to have the real-time experience, but it seemed that it's a bit difficult to set it up. The documentation for the previous version was quite okay, but again, you need experts for this kind of tool, to be able to deploy it. So it was a bit difficult. Not much documentation was made for the new version, which we were kind of hoping for. The new stack, it looked kind of nice. You could put it in Grafana, right, like many of you do. But again, the documentation was not really there, but it looks promising. Like, we really saw what it can do. We played with it, but again, we could not really deploy it well so that it would be able to be used. And by our observation, again, I would definitely recommend you maybe waiting and focusing on the new version, which is getting updates almost monthly or by 2 months. So definitely something that you can look into. Another big challenge was the config, because it's endless almost sometimes, and it's difficult to follow, right? You have a big config, and what you can do, it's you can build your image, then you can run it, but then you try to do something and it fails, and you can repeat that. Or you can just somehow import the config, restart it, and do your magic, which we did. But again, finding out what parameter is wrong, looking through the documentation, it was cumbersome. It was tiring and frustrating. And we would suggest you just using automated tests or some setup automation that can help you with that. Another challenge that was mentioned a bit is the synchronization of the nodes. Particularly, we meant node as the Kamailio and RTPengines. You might see, again, lower resolution on the top right. I'm sorry, it's from the academic paper, that they were thinking of having some kind of a leader, then figuring out what pod is available, is a bit emptier, so that there would be less failover and stuff like that, redundancy, that's nice, but they were using the daemon set. So this was not really handled in our particular case. Definitely there are options with other caches, some redirections, so definitely there are options to solve that, but it's not natively covered. And I think there is another security challenge, because you might have seen, if you were looking right, that the RTPengine should go through the deployment, right, from the pod, right? And that's connected to a node, right? So you would need to expose node interface in order to communicate with that. And again, this is a bit solvable, but needs additional steps for you to solve. So it's not as straightforward as you might think. And another challenge was the scaling. As I said, it was to X numbers, so it wasn't nothing too high, but also nothing too small. But as you can see that Kamailio can handle millions of calls, as I mentioned, in the benefits, but the RTP needs a lot of resources in order to do the media translations. On the top right, on the bottom right, you may see that there was a peak at 150 calls per RTPengine, and then the quality was way worse. So we figured out that we can use RTPengine for 150 calls, and after that we need to find a different RTPengine. Another thing that's quite a challenge here is that for a call to happen, you need 2 ports open. And I think I will just follow up on that in the next slide. But I want to mention also the configuration management is the key. As you saw, that you needed to have like an operator handling these config maps in order for the Kamailios and RTPengines to be synced. And quite not really nice feature is that you can do a restart in runtime, but they say in milliseconds. But what if it goes to seconds, right? You can maybe cause some outage or something. So again, the configurational management is a bit hard. And the challenge that was presented was the ports, right? So by native Kubernetes deployment or setup has some node port limitations, right? And you can see on the picture that you have somewhat of 2,700 free, right? But the call needs 2, so technically you wouldn't be able to scale to millions of calls per your setup. So. And you might see that the RTPengine needs annually 1,024 to 65K, which is understandable because these deployments are not made for Kubernetes natively. It was made for virtual machines or containers on Docker just for experimental reasons. So another a solution has been brought to us, and that's using Multus. Maybe if you have heard about it, but it's a CNI that allows you to create more network interfaces. So technically, you could use this strategy to have more ports for your setup. But if you opt for this, then you need to figure out something about network management, because you do certain features that Kubernetes provides you by default on the network side, such as service discovery, and I think you will lose cluster IPs and much more. So you need to handle that if you want to use Multus. But that's about it for the challenges. Here is the conclusion. And I wanted to mention that the telco environment is evolving and moving to being cloud native, and we want to be part of that. When it comes to Kamailio and RTPengines, not all is really easy. You have the configuration, you have the documentation, you have the test, and you need to do so much more to it being operable. But if you know what pain points are when you're running voice applications or stateful workloads like that in the cloud, you need to be thinking primarily of the infrastructure and planning on how it actually is going to work, what you need, what are your requirements, before you try some solutions there is. And the other 2 points are that open source tools actually exist for telecommunications companies and that they are using them. And it's nice to see that we are also part of that. And last point that I want to mention is that creating a voice platform can be hard and challenging, but after the pain, it's definitely doable and achievable, and you can create it on your own. And I think here is going to be the part for questions and answers. I don't know if I will see the Slido or someone's going to come to me.
Welcome.
All right, thank you so much.
So first question, how is difficult exposed telecom services in Kubernetes when it does not even allow to specify port ranges for services? Is there any standard solution?
For specifying ports for telecommunication workload or in Kubernetes? Was a question like that?
Yep.
That was my question. My question was, is there any specific? Yeah, thanks. That was my question. I asked if there are any common solution which telecom companies use to expose the RTP services in Kubernetes.
I know that there's not like a standard way, because I think this is widely used in the operator space. So technically, like, you have security concepts when it comes to like real production. But if you do like like this SBC, yeah, it's quite sometimes insecure, and the academic paper talks about it. Like, there are solutions 100%. I couldn't really explain it here over now, but like definitely you can. I will show the references, and you can also like use it up. But yeah, it's like one of the major security challenge that you need to solve, to secure your deployment or usage. But there are different types of solutions. So we presented only, what you can do like that. But there are definitely, I think, like other solutions that take advantage of, it being secure, or there's some security on top of it to protect it, right? So you can use some public or private, or you can use subnetting, right? Or in network you can definitely secure it in a way that it's possible to use this solution. Yeah, definitely. But we weren't really focusing on this because we had it on private infrastructure, so we had everything secure, so we didn't really need to think that hard in terms of security because we were running it privately, so yeah. Thank you, though.
Okay, another question. What are the main challenges with the gateway session routing for real-time voice?
Oh yeah, that's a good question. It's so difficult. Yeah, I know that we were thinking of like sticky sessions and stuff like that, to have like sessions. We know that the load balancers are smart, so that you can put your session ID and stuff like that and get routed. And as well, Kamailio provides a way on how you can do these sessions by geolocation. So I don't know, if I send a request over here, it will have the geo coordinates, and it will know where to route it to. So it has its possible ways on solving this. Yeah, definitely sessions are part of that. And you can do it with a load balancer, or you can do like Kamailio to load balance it for you. So there are multiple options on how you can do that.
Okay, another nice question.
I know that some of my colleagues are watching and providing some question.
So, in addition to what you already answered, do you use any special gateway solution, or Kamailio is providing it?
Yeah, so I think we were using the load balancer that was in our private infrastructure, so we didn't really need to think about it. But Kamailio can provide that. Definitely can work as a proxy or a load balancer. It has more uses, and I think there are also different types of load balancers that you can use with the voice to distribute it with your parameters, or you can do some inspection and you know where to send it to.
So next question.
Shoot it.
Please, how many calls can you handle by a single instance? Did you implement automatic scaling? Any feedback from the production?
I think this one is from Tushar. But so yeah, we were able to do multiple calls. Definitely, we were able to scale. I think like we had it at I don't know, 4 Kamailios or something like that, because we don't need to really scale that, so we had it on lower end. But the RTPengines we were testing, if you have 2 plus or 4, to see if it works or not. And so we were able to use the testing, and that was quite nice. It was showing good results. But whenever we did some changes in the load balancer, it behaved quite poorly, and some of the calls were not working. So it was a bit difficult, but yeah, as I mentioned, Kamailio can handle millions of calls, and RTPengines, again, like around 150, but you don't want to get there, right? You want to do like 120, yeah, something like that. And in terms of cost, was there something like that, or?
It's already disappeared. So.
Oh shit, okay.
Maybe Pavel, if you can
I know
revert it. So.
I know who it was, though. I can tell him.
So, the next one. You mentioned the cluster was air-gapped.
Yes.
Can you elaborate it more?
Yeah, so in terms of the air-gapped environment, we have this on our private cloud. So we have huge restrictions on that. Like if you have customer data, it depends on what. So you have different grades or tiers that can be exposed or not. And during this project, we had everything running on private infrastructure, so you had to have some certain workflow that you can work with that. And the internet was not present, so we needed to handle it via mirroring repos, having private Artifactory. Every image was scanned, and some security concepts over there. So it couldn't communicate with the internet or download stuff or be exposed to the internet. So it was air-gapped. We call it like that. Yeah, just there was like a thin line, I guess.
Okay, back to the previous question. It was how many calls can you handle by a single instance? Did you implement automatic scaling? Any feedback from the production?
Yeah, good point. Yeah, automatic scaling, we weren't able to achieve some HPA or some scaling based on the data. Again, it was just our limitations because we had the native Kubernetes deployment, so standard, less ports, so we couldn't really scale to big numbers, with the metrics and stuff if we implemented that. So we weren't able to because, of the architecture that we have now. We are, focusing on the multis. We want to, see how can we do it with multis and to extend the port range. And to the production ready, that was a good question because we had the same presentation to our management and that was the first question actually. So, but we think that it's not right now production ready. It was, I guess like a project to figure out if it even works and that if we can really like use it and have some workflows running. So that was.
Okay, thank you. We have another question, but I think you already answered it by Martin. Is your Kamailio-based solution working now in the production? So
it's not. No, definitely. Like there are so many. Like again, security topics, again, some redundancy topics, so you don't want your call to drop, right? And stuff like that. So you need to really think of like bulletproof solution that you can handle these calls. And in the beginning, we weren't trying to replace the current solution because that would be deadly. And for a couple of people, I don't know, 4 or 5, like create this platform on ourselves. And it was not our primarily like project. It was like we worked on it on. I don't know, 2 days, 1 day a week, in over a year. So like it was just like a side project. So we weren't even thinking of putting this into production. We just wanted to, again, get the knowledge, see what can work. And just build like a small platform that you can do these kinds of calls and stuff like that.
Okay, we can move on. Did you find any interesting tools for networking management automation with MATLAB CNI? Do you plan to outsource any of your achievements?
Oh, interesting. For the network configurational management, I know that this was one architect's like primarily research with the multis. So I can't really. I mean, we can maybe chat after this presentation on about that. I see that there has to be some sort of automation on the network. Definitely some work has to be done over there, but we weren't, needing it because we had again like a different architecture, different deployment, and it would be way easier to have it on this new upgraded one with multis, and we would need to sort it out. Yeah, definitely introducing some service concepts and definitely putting more effort into that, but we really didn't. We just focused, on how to easily deploy it on native Kubernetes with the tools that we had tested with Kamailio and RTPengine if it really works, and these were our like objectives.
And what about second part? Do you plan to outsource any of your achievement?
We were thinking about contributing to the Kamailio, but I think we still need to think about that because again, like we see that it has flaws, right? So we wouldn't be able to open source this because again, I think many companies are doing it, especially with the collaboration of the Kamailio company or like SIP. I think they're called SIPwise or SIP Capture or something like that. And they are providing the services on how to set it up, how to do it, and stuff like that. So us outsourcing it would not make sense. You can directly talk to the people who created it, right? It would be easier to set up, instead of our solution. So no, it would be primarily in-house. I think there were no discussion on outsourcing it or doing something to it. Yeah.
Okay, the next one. With heavy use of node ports and 32,000 port limit, do you see any kernel changes in IP tables?
Oh yeah, that was one of the issues. I think in terms of the it would become slow. I think that was the performance issue. That if you're adding so much IPs and stuff like that, it would slow down. We know that you could technically update it yourself somehow. I know maybe I know the owner of this question again, but. Yeah, definitely. I think there is a way. I know that there is even like a tool that can help you with the speed and efficiency. Like you could use Redis for caching inside of the Kamailio solution, or you can use HTables that are quite quick in what you want to do. But I know that this was a discussion in the academic paper too about the what's fast or not in connected with the IP tables. Yeah, like because if you have a lot of them, it can slow down the performance. So. Yeah, I know about it, but again, it would be redirected to my other colleagues. Sorry for that.
Okay, maybe I can add something. So, did you think about NF tables or even BF filter, instead of IP tables?
Yeah, I Yeah, I understand. I think like, yeah, there are options that you can have it implemented. I think we just have the native IP tables again because we weren't scaling to big numbers, so we didn't really care about the performance in that way right now. But definitely, if we had thousands, millions of calls, you would need to figure out, you know, if you opt for something modern instead of ITP tables, yeah, some virtual, yeah. So yeah, but in our case, in our project, we that was out of our scope, yeah, especially with the people that we had. Yeah, it was just.
Okay. You decided to run the RTPengine as deployment. I guess the traffic is UDP. What load balancer do you use? Can a single call session survive a pod outage?
Oh, that's another good point, yeah. So we were just using, as of now, the native Kubernetes load balancer. Definitely you can use another RTPengine in front of it as a load balancer, that's possible too. In terms of the daemon sets and deployment, I try to mention, you know, the difference that if you use the daemon set, it's quite limited, scaling and stuff like that. If you have deployment, it needs a lot, plus the redundancy topic. Yeah, that's one of the pinpoints. I think if your pod dies, especially with the media, it's highly not probable that Kamailio would die, but it can happen too. But yeah, this is a topic for redundancy, and yeah, during our research, we figured out that if you have redundant pods from the RTP engines, what you could do, you could cache them so that you would have the sessions IDs, you would have the possibility, I think, to store that, and if there was a failover, you would need to have like an operator checking the statuses and stuff like that, and in real time, like you wouldn't, like you can't wait like a minute, you know, oh, something's wrong, right? Call is dropping, right? So there were concepts on how to handle this redundancy. You would run more RTP engines ready, and you would need to have a concept on how to provide that the redirects happen. I think in Kamailio you can do it. You can rewrite the data. You can add to the data more, so like you can have a mechanism on top of it, some process checking if everything is well, if the flows are running, you know, or some parameters in the calls, like you can do that. You can do jitter or some other parameters of the call, like if it's quality one or if it's failing or something like that. So definitely, I think like you can definitely implement that. On the other hand, it might be difficult. Yeah, you will have a trade-off. I think, you know, if you know this fails, you need to have this open. So there may be like a fallback route or something like that created to inform the both parties. Hey, let's switch up to a different pod because it's not working on this port, yeah. So I think it was in the academic paper that I showed you too, yeah, this failover. Okay,
the last question on Slido is, what's the name of the load balancer? We already spoke about it, but maybe, I'm not sure if they ask about the ingress controller or just load balancer, so maybe...
Yeah, so you saw that there was like a load balance in front of it? I don't know, maybe I can...
I think they ask more about the ingress controller, but...
Yeah, so we use the Nginx ingress controller.
Yeah. I mean, the Kubernetes ones.
Yeah. So we wanted to just like opt for the native everything. Like we didn't want to really introduce something new. We didn't want to really experiment that much because we, you know, thought that, you know, hey, if this exists, like, why don't we try this, right? So, and then we would figure out, oh, this is bad, this is wrong. Like, we can do it like that. Or if we're gonna get a something from a vendor, like we know, hey, this can be wrong or something like that, and we can, you know, have some you know, knowledge in that. So yeah, we were using Nginx ingress controller.
Is there any question from the audience?
Then if not, I want to give big thanks to my manager, Yishi Hayek. I think he's in the crowd. The facility for hosting us, for providing this venue. The Cloud Native Prague organizers, definitely huge shout out. And major thanks to my team for making this happen, because without them, I wouldn't be presenting here and, you know, creating this solution. So big thanks to them. And here are the references, so like you can, you know, view what I showed you. And thank you all for coming for my presentation. That's it. Thank you guys, and enjoy.
Thank you, Martin. We will have a 15 minutes break, and then will be the second speech, so you can grab some food and drinks. Just make it. Thanks.
Trust, and I gave you everything that you need. But you only told me lies, and you made me realize it, babe. Gonna hit the ground running, baby, I'm running, baby, I'm running, 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 ground running, running, running just as fast as I can. Gonna hit the ground running, running, running just as fast as I can. Gonna hit the ground running, ooh, oh, running, baby, baby, running, running now. Ooh, running just as fast as I'm running, just as fast as I can. Life is cinematic, I'm an instant classic. Living in the fast lane, can't nobody pass me. How I spit the drama, I bet that you wanna know. Whoa. Hey, catch me in a photo, I stay riding solo. I ain't got the patience, permanent vacation. Everywhere that I go, I still gotta be in my zone. 'Cause I can't stop moving in my own way. I can't stop doing it my own way. I can't stop living in my own way, in my own way, in my own way. I can't stop moving in my own way. I can't stop doing it my own way. I can't stop living in my own way, oh, in my own way. Yeah, gotta live a little, meet me in the middle. Switch it in a high gear, I'ma head a light gear. Even though I'm winning, you know I still keeping it cool. Yeah, so cool, yeah. Chasing motivation, once a generation. Obstacles are bogus, I just gotta focus. Set the expectation, I can't wait to see what I do. What I do. I can't stop moving in my own way. I can't stop doing it my own way. I can't stop living in my own way, in my own way, in my own way. I can't stop moving in my own way. I can't stop doing it my own way. I can't stop living in my own way, oh, in my own way. Can't nobody tell me what I can't do. No, no. Can't nobody tell me who to be. No, no. Do it for myself, I make my own rules. Living in this life, I must be free. I can't stop moving in my own way. I can't stop doing it my own way. I can't stop living in my own way, in my own way, in my own way. I can't stop moving in my own way. I can't stop doing it my own way. I can't stop living in my own way, oh, in my own way. Tell me something, it might just take the pain away. See, I've been thinking a million things I want to say. Now I'm looking in your eyes, but I'm wandering to your lips. See, I'm trying to keep it cool while I'm hovering for the kiss. 'Cause I've been needing you like old-fashioned orange slice, sweet like daiquiri with strawberry crushed ice. Know you like a margarita with the hot spice. Love the taste of paradise. No, it's never been the right time. Like we're holding back the storyline. And I'm waiting at the end of the night, thinking of you. To You got what I need. Sipping on the potion, all that good emotion, just my kind of heat. Keep it on repeat, tested by the potion, loving this devotion. Live it up, live it up, live it up, sweet emotion. Every time, every night, you and I on a roll. Switch it up, switch it up, switch it up where I'm going. Stay on the fly just in time, know the right way to go. I'm on the road, it's my time, taking control of my life. I want to run the red lights, I've got to run this show. You always take me
So take your seats, we will start. So I'd like to welcome on stage second speaker, Andrei, and he will be speaking about Cozystack. So please welcome.
Thank you. I will speak not exactly about Cozystack, but about the technologies we used and how we organized storage subsystem and how we utilize it. This is very interesting. I will start with introducing myself. Okay, now we have one slide back. So can we somehow synchronize it? Or okay, I'll just take a look at this screen instead. So I started my Kubernetes experience working for Vedos. Vedos is biggest Czech hosting company. We were doing a lot of interesting stuff, and I was working with Kubernetes, especially for bare metal. We were running Apache services and multiple virtual machines and things like so. Like it was very amazing, interesting job. Then I switched working for Pelerg. I was developing Deckhouse Kubernetes platform, where we introduced also virtualization and storage system. And now I'm founded a new company which is called Ionix, and we develop open source software for providing managed services, just like AWS, but on your own on-prem environment. The idea of the Cozystack that you can take bunch of servers and convert them into cloud system with Kubernetes API, with monitoring enabled, and all the opportunities inside. This is how it looks like. So you have dashboard where you can click and install any application you want to. You can run Kubernetes. You can run Kubernetes inside of the Kubernetes. The same Kubernetes, Postgres cluster, MariaDB, and things like so. Every application can be configured, so you can specify it like normal YAML in Kubernetes. It has its own Kubernetes objects. And now I'll share information how we actually built the platform. It consists of few layers. The layer 1 is operating system and Kubernetes, and we depend on Talos Linux here. On layer 2, we have storage. For storage, we use LINSTOR. LINSTOR is open source solution which allows you to order PVCs on bare metal servers and enable replication for them. For networking, we use OVN. OVN is a solution which is specific CNI, which has extended opportunity to specify multiple networks and consume it for virtual machines. So it works well with KubeVirt. And for virtualization, we use KubeVirt. On top of this, we also built the layer of operators, cluster API, monitoring system. And on the final layer, we say application layer, where users can order their own services. We have managed databases, virtual machines, and managed Kubernetes. So today I'm going to show you how we utilize the storage and how we organize the system, how we deliver all of these components. From my perspective, it's a very interesting topic. So for layer 1, we use Talos Linux. Then the rest layers are managed by Fluxcd. And finally, we have specific Kubernetes aggregation API server, which translates Fluxcd resources to the Kubernetes objects. Let's first speak about layer 1, about Talos Linux. Talos Linux is Kubernetes-oriented distribution. It is very specific, and it can be used only for Kubernetes. It actually have the single purpose operating system to run Kubernetes clusters. It is not normal operating system which you can use like login over SSH and install some packets. It has single core, and it has API server which is very similar to Kubernetes has. So you can configure Talos Linux with a single YAML format, a single YAML config, and this is how it looks like. It has actually two sections, machine one, where you can specify configuration for the machine, and cluster section, where you can specify the configuration for your Kubernetes cluster. So in machine section, you can specify a type of machine, either control plane or worker, specify certificates because Talos runs its own API. And it should listen on specific certificates. You can specify settings for networking. You can see also VIP address there, so it has built-in opportunities for load balancers, and disk to install the system itself. While cluster section includes endpoint, this is normal Kubernetes endpoint, which will be working after Kubernetes will up and running. The same certificates and configuration for Kubernetes components. So if you want to install Talos Linux, you just need to specify to write this configuration file and use talosctl apply tool to apply it to Kubernetes similar API server running on the virtual machine. After that, it will just start running, and you will have Kubernetes cluster ready to use. But with bare metal, you always have some issues because virtual machines are kind of similar, but bare metal servers are not. Since we are renting on ISPs and we interested to work with bare metal machines, we did some enhancements and some approaches we used to adopt Talos Linux for bare metal machines. So when you have bare metal servers, you always have to worry about firmwares and kernel modules, how to update them. You still have to worry about how to boot Talos Linux image on those nodes, because they usually have no virtual CD-ROM where you can install, where you can put virtual ISO. So you can do that through the PXE, or you can use RTPengine. Still questions about how to specify proper disks and interfaces for every machine, because we remember that every server is different. Every server have different MAC addresses and disks, and you need to find convenient way to specify everything in this configuration. First, think about firmwares and kernel modules. We solve them by baking our own Talos Linux image. So we specify that it has specific firmwares and also kernel modules we use. For example, our storage is working right in kernel, and we use such modules like DRBD and ZFS. So you can bake your own Talos Linux image by writing similar YAML file where you just specify extensions you want to. Here are firmwares, and here kernel modules. So after this, you push this YAML file into Docker, and finally you get image which you can boot any method you like to. So you can use PXE or you can use RTPengine. This image will hold all the needed kernel modules and everything you want to. For orchestrating this, we created our tool that's actually shell script, which allows you to start using Talos Linux faster. It's called Talos Bootstrap. We really like PXE method, so we also provide our image, Docker image with our image for booting. So, and this tool, you can use it to configure the servers. First, you boot servers from these Docker containers, then you use this tool for configuring Talos itself. This is how it looks like. It's actually, it can find all the nodes you have in your network. Then you can put host name, disk to install, some network settings, and finally it will generate Talos configuration, which will be then applied to the node. And node get installed. Actually, you can set up your own Kubernetes cluster on bare metal very quickly, and you'll get ready Kubernetes cluster to use. But that's not the thing. Yeah, inside of this, every virtual machine you will have prepared image with exact kernel modules and exact kernel version. That actually allows us to do stable base for the rest of the system. And speaking about the next layers, how actually we deliver all of these components. we use FluxCD, but we do really interesting logic to start. Before you start using FluxCD, you need to somehow install FluxCD itself. And so you need to configure CNI and other stuff before it can start working. So we let our users to apply a single configuration file, which will create one container, deployment with one container. Inside of this container, we have a repository with Helm charts, and we also have small shell script which will install CNI and FluxCD. Then all the rest logic is get done by FluxCD. So it delivers all the system components into the same cluster where it is running, using the Helm charts repository running the same cluster. If we want to update the platform itself, we just replace this container with new one, and FluxCD just delivers the rest of the components into the same cluster. This way, we achieved we made our environments reproducible, and they always have the same kernel, same modules, and the same components installed inside. This way we deliver the storage. The LINSTOR is the storage based on, it's not like storage system, it's more likely orchestrator. It's like Kubernetes, but for block devices. Kubernetes works with well-known technologies like LVM and ZFS, so it can cut volumes it can be integrated with Kubernetes itself, and it can cut volumes from LVM and give it to your workloads. If you need to have replication, you can use DRBD to enable replication of those volumes between the nodes. It also has some extra features. For example, it supports encryption, deduplication, but we don't use them right now. Actually, using LINSTOR on bare metal cluster allows us to have almost native performance of the storage system on the bare metal node. We also have networking, which is based on Cilium and KubeVN. KubeVN works well for virtual machines. It can remember MAC address and IP address, and it also allows you to live migrate virtual machines from one node to another. Also, we ship monitoring system, virtualization based on KubeVirt, and all of these open source components from which our platform is made of. Yeah, here are some charts why we choose exactly LINSTOR over Ceph. We also use Victoria metrics instead of Prometheus because we really want to get most performance what we can get from the bare metal nodes. In those charts, you can see that it's usually faster almost in 7 or 10 times and more productive than the other upstream technologies. And finally, the most interesting part, how do we use this stack and how we use storage? We use it different for all of these components, for databases, for virtual machines, and for managed Kubernetes cluster we're running on top of this platform. By the way, all of these components, like managed Kubernetes databases and virtual machines, they are managed by operators. Only operators can provide you opportunity to have full lifecycle management for your application. So if you just use Helm charts, it can put some YAMLs into cluster, but it will not take care about the state. We have a hybrid approach where every application here is actually a Helm chart, but it puts YAML files for operators. And for all of these Helm charts, we also built our own aggregation API server, which translates them, actually Flux-ready resources, to Kubernetes objects. That actually allows you to simply extend the platform itself, the new type of resources, just by simplifying them as Helm charts. And let's speak about the storage itself. The database is managed by ordinary operators. We use CNPG for Postgres and StreamZ for Kafka. But we extended with our Helm charts some added extra logic for keeping dashboards, for Grafana, and configuring users. So actually, the storage we use for database, yeah, that's a set of operators we use in Cozystack. If you want to get any database installed, you just click and install, or you just specify YAML manifest in Kubernetes. Then it gets managed by operator framework, by operators, specific operator for this database. For example, here, if you want to create a Redis application, you can specify bare minimum of the parameters. It will create few resources like Redis failover for the operator, service for accessing, and also additional resource for the Victoria metrics. In terms of storage, we have this logic. Let's take a look. For example, we have 3 nodes. We have some storage pre-configured on them, and we don't use replication for database. We don't use storage-based replication. So we expect that database can be created in cluster mode, and it will replicate it on application layer. So in case if we create new Postgres cluster, it will create 2 Postgres replicas, and every replica will have its own volume on the node where is it running, and it will replicate each other and manage it by the operator. So this approach we use for databases, and those databases running right on bare metal nodes, which gives you ultimate bare metal performance. But in case if we want to let user running their own workloads, we can just let them running what they want to in our management Kubernetes cluster. So for user workloads, we always expect that user will create their own virtual machine or managed Kubernetes cluster. For virtual machine, the logic is the same. So we open dashboard, create virtual machine resource, which is actually Helm. It creates YAML for KubeVirt, and it's managed by KubeVirt, actually creating the virtual machine. From the storage perspective, we can't create multiple replicas of the same virtual machine because it does not work like that. The virtual machine can be running just once in single replica, but we need to have some redundancy for it. So when you create virtual machine, we use different storage class, which just creates 3 replicas for storage, and it also enables fencing. That means if node go down, the virtual machine can be moved to another node, and it will always work with the same storage, with the same PVC, which is now replicated. And the most interesting part, how do we organize tenant Kubernetes clusters? Yeah, we run Kubernetes inside of the Kubernetes. This is actually done the same thanks to Helm. We use Helm, which sets up components which are managed by Cluster API, Kamailio, and KubeVirt. Kamailio is, I would say, it's kind of operator for Kubernetes control plane. So using Kamailio, you can create custom resource which will create standard Kubernetes control plane components inside of the working Kubernetes. We use Cluster API to control this. Inside of the management Kubernetes cluster, we have this Cluster API that allows us to run multiple tenant Kubernetes cluster in specific namespaces. But there are still questions how to configure Cloud Controller Manager, CNI, and storage and cluster autoscaler, because it's not just simple run virtual machines and install Kubernetes on them. You need to have full integration with cloud to make this Kubernetes fully functional. So we use FluxCD to install all of these components the same like in management Kubernetes cluster and the tenant Kubernetes cluster, which just created and running with virtual machines. Inside of the management Kubernetes cluster, we have this tenant control plane, which holds all of these Kubernetes components like API server, controller manager, scheduler. We're also running separate CCM for KubeVirt and CSI controller. That's just part of the CSI driver, which controls creation of the volumes and attachment and things like so. We also have cluster autoscaler, which creates needed amount of workers. It takes a look inside of the tenant Kubernetes cluster, checks if it needs to create new workers, and actually create workers. Inside of the workers, we have CNI plugin installed, ordinary Cilium, and CSI node part, which is which controls the attachment of the volumes after it gets attached to the node. It can actually mount it and run for the volumes inside of the tenant Kubernetes cluster. Yeah. And now we are going to talk about this part, how it works. So if you run virtual machine, in terms of management Kubernetes cluster, this is ordinary pod. In case if you have 2 virtual machines, you have just 2 pods. If user runs inside of this virtual machine, inside of the virtual Kubernetes, their own pod, and this pod requires you to use some persistent volume claim, the new persistent volume claim and persistent volume in management Kubernetes cluster will be created. Then KubeVirt creates additional pod, which calls hot plug volume, and it handles its own logic, which will pass through this volume 1 into this virtual machine, and then attach it to the pod. Slightly difficult logic, but it works. For user data, we can't be sure if they're running such things like Postgres clusters, so we always want to have this data replicated. So for this data, we also use replicated storage class, which enables this replication thanks to DRBD. In case if user runs pod on another node, it can also attach it on another node with the same logic done by KubeVirt project. This way we actually implement the fully functional Kubernetes, which has load balancers, persistent volumes, and a cluster autoscaling. Also the rest things which get used to have in every cloud. Cozystack now CNCF sandbox project. Thanks to our community, many features are appearing. Please join our community, and we have community meetings as well. I'll provide some links about the projects I talk about. So the first is Cozystack, second is Talos Linux, which we use for operating system. Piraeus data store is the storage I was talking about, and set of my articles which describes how all of this working together. Here you can see other my speeches. If you're interested, I have many of them. Thank you. Now I'm ready to answer your questions.
So, when you install Talos on bare metal, how do you ensure that the disk is /dev/SDA?
Good question. The method I show in this presentation, I will not click it back because there are so many slides, sorry. So we have 2 methods. The method 1 is Talos Bootstrap. It was the tool which also manufactured by the reason that every bare metal server is different and we need to get this information. Talos Bootstrap allows you to provide a list. How this list generated, it's just API call to Talos API before the config is applied. We also have another tool which allows you to declaratively set up Talos itself. It's called Talm, just like Helm, but Talm. It's like Helm for Talos Linux. It allows you to use tools like lookup, functions like lookup, to query Talos API and generate uconfig with your own custom logic.
Okay, second question. How do you handle the node eviction, failures, upgrades?
As about upgrading, thanks to Talos, some logic is automated. So in case if you want to update your node, you can apply new configuration file, then run one call, which will first evict all the pods from the Talos, from this exactly node, then reboot the node, then turn it back to the cluster and remove this taint. As about failures, this is a good question. For now, we have storage-based fencing. It is also supported by Piraeus project, by LINSTOR. So with the storage, it ships specific controller, which checks if I would say every volume in Kubernetes in LINSTOR, it has quorum, and if quorum loss, then it can guarantee you that the workload can be running on different nodes. So in this way, it will just go to Kubernetes API, remove the pod, which currently can't be running on another node. And this way, the high availability will be ensured.
Okay. Is there any question from audience? Here. Wait.
So my question is about the layer 4. You said you can define it with YAML, like database or something. So can you have it like in some Git repository and then Cozystack will scan it? Or?
For now, we're trying to build everything in tree. So we distribute the platform the same way. We have repository inside of the platform. This is not Git repository, it's Helm charts museum. But all of this is built out of the Git source tree. You can take a look at our source code. All of those Helm charts and configuration is stored there. So if you want to extend the platform with new types, you can actually specify new Helm charts in this. For now, you actually need to rebuild the platform. But all you have there is just simple YAML configuration. So the platform itself is fully built. I would say it's written on YAML, on Helm templates. And to extend those kinds, we just have a config map which describes which kinds should be translated to different Helm releases. This is done by Kubernetes aggregation API server.
So in the Helm chart, it's like some resources that will be then picked up by some operator?
Yeah, inside of Helm chart, you have a few resources for the operator.
Yeah.
This way we have flexibility because you can specify your own custom Helm charts and you can specify specific values which are possible to change by the user, because you don't want user to change everything in operator. They can overwrite image and compromise the management cluster. So if you need to add your own application, you create your own Helm chart. In values, you specify the values they allow to change, and then extend configuration file for our API server, which also publishes it as Kubernetes object. It's pretty similar to CRDs, but without state. So we don't sync the state between our custom resources. They translate it on the fly.
Thanks.
So we have another question in Slido. So what would happen to Cozystack if Cider Labs bankrupted and Talos would stop being developed?
Good question. We are not very dependent on Talos Linux. Moreover, we're about to add another support of Ubuntu and other public distributions. So the main value of Cozystack is to provide ready configuration, ready to use of all of these open source components. And Talos Linux is just one of the components which is replaceable.
Any other question? Oh, okay.
Thank you for the talk. So the Talos doesn't have any package management, but you can install some modules there. But if there is, for example, NVIDIA modules, it needs DateKMS. So can you install some binaries to the Talos or not?
Thank you for the question. Talos itself can be configured on the build phase. When it already built, there is no opportunity to inject any modules, so you can't even use some kind of DKMS, or the insmod command is prohibited by the kernel itself. You can inject only modules which have compiled while the Talos Linux, while the Linux kernel was built for the Talos. So the Talos itself have the structure of such packages, but they can be used only while you're building your own custom Talos Linux image. If you use factory.talos.dev, they also use this extension, so you can specify with the check marks the modules you want to, and in output you always will have one single image baked, which you will just use with no opportunity to inject any custom modules inside of them.
Thank you.
So, no other? Okay, so I have one. How do you handle disk encryption?
Encryption? Disk encryption?
Disk encryption.
We actually rely on LINSTOR logic. It has LUKS layer, so you can create additional config map or secret with master passphrase. And then in your storage class, you can specify that this volume should be encrypted. And then it will create, like usual, ZFS. We use ZFS, but it can also work with LVM. So it creates some block volume. On top of this, it creates LUKS. And on top of this, it creates DIRBD, which also replicates it between 2 servers or even more servers.
Okay, thank you. If there is no other questions, so thank you for your talk.
Thank you for listening.
And we can continue the networking part, so don't leave it. Just take some food and we can talk about what you want. So, thank you.